Today we're going to look at section 4.3, which is properties of logarithms. So today we're going to use the product rule, the quotient rule, the power rule, and we're going to expand logarithmic expressions. Remember, logs are exponents. So therefore, any property of exponents is going to correspond to the properties of logarithms. Okay, so thinking about all the different properties. So hopefully like product and the product rule and the quotient rule, you're probably thinking, hey, that sounds familiar. Well, yeah, we did that with exponents. And so now there's going to be a similarity when we're talking about them with logs. So the product rule. So remember, when we were talking about exponents, as long as the base was the same, if they were being multiplied together, we kept the base and we added the exponents. So we're going to have something very similar now if we're talking about logs and the product rule. So let b, m, and n be positive real numbers where b does not equal 1. Log base b of m times n is going to equal log base b of m plus log base b of n. Okay, so notice that we're dealing with the product and it got split up into addition. Just like here, we had the product and it got turned into addition. So the only other thing that we have to be very careful with was notice that we have to make sure that we are keeping the same base with each of the logs that get added together due to this product rule. Okay, so the logarithm of a product is the sum of the logarithms. Okay, so let's use the product rule to expand each logarithmic expression. So here we have log base 6 of 7 times 11. So because there is a product happening inside of the parentheses, we are going to be able to split this apart. We're going to write log base 6, and then I'm going to put the first number, which is 7. And then based off of our rule, product means we are going to add, and then we're going to write log base 6 again. And now we're going to put the second number, which is 11. If I could simplify this, then I want to. So if I'm looking at log base 6 of 7, remember that means, okay, can I take 6 to some power and make that turn into 7? So hopefully we notice no, 6 to some power is not going to get me 7. Same idea then with the second term. If I have 6 to some power, is that going to equal 11? Well, my answer is no. So there's no way I can simplify this any further. So I've broken it up into the log base 6 of adding those two things. And so there's my answer. Okay, if I take a look at the second one, we have log of 100x. Okay, so remember, anytime I don't see a base, it really is a base 10, but we don't have to write that. Okay, so notice that we do have the product. It's 100 times x. So I'm going to have log of 100 plus log of x. Okay, once again, because you can think of that log as a base of 10, can I simplify this? Can I take 10 to some power and make it equal 100? And hopefully we all notice that yes, 10 squared is going to be 100. So this log of 100 really simplifies to the number 2. Now, because in the second term, we're dealing with a variable, well, we're not going to be able to simplify that any further. So 2 plus log of x would be my expanded answer. All right, let's talk about the quotient rule. So remember, in terms of exponents, if I have b to the power of m divided by b to the power of n, so they have the same base b, and I'm talking division, which means quotient. Notice how we kept the base, and then we took the top exponent minus the bottom exponent. So here's our definition when it relates to logs. It says let b, m, and n be positive real numbers where b does not equal 1. Log base b of m divided by n is going to equal log base b of m minus log base b of n. So notice that the top term here is the first term, just like here, m was first when we were subtracting. Okay, but same thing. Notice that the base b is common throughout our subtraction. So notice that the number that we end with in our denominator is the second term. Okay, so the logarithm of a quotient is the difference of the logarithms. All right, let's take a look at a couple of examples. So we're going to use the quotient rule to expand each log expression. We have log base 8 of 23 divided by x. So we're going to start with log base 8. We'll write the first term in the numerator, so 23. Division means we want to subtract. Now we'll go back to writing log base 8, and now I want my denominator of x. Once again, if I can simplify, then I want to. So since the first term has all numbers, 8 to some power, can I make that turn into 23? And the answer is no. And because the second term has an x, we're not going to be able to simplify that. So this would then stay my final expanded answer. In the second example, we have the natural log of e to the fifth divided by 11. So remember, natural log is a log. So its properties are going to follow what we were just talking about. I get to write the natural log, so ln, don't forget that's an L and not an I. We'll take the numerator, which is e to the fifth power, minus, then we're going to be taking the natural log of 11. So don't forget that, like I said, natural log is log base e. So my first term has a base of e and has a base of e for its exponent as well. So remember, based off of our rule, those are inverses, those cancel. So this is going to simplify to the number 5. But the natural log of 11 is not going to simplify any further. So that can stay natural log of 11. And this would be my expanded simplified answer. All right, the power rule. So remember, in terms of exponents, if I have an exponent raised to an exponent, so a power raised to a power, we keep the base and we multiply the exponents. So in terms of logs, it says let b, m, and n be positive real numbers with b not equaling 1. And now we have this letter p, which is any real number. So log base b of m to the power p is going to equal p times log base b of m. So notice that the exponents got moved out in front and now is being multiplied. So that's where the multiplication comes into play. So the logarithm of a number with an exponent is the product of the exponent and the logarithm of that number. All right, so let's use the power rule to expand. We've got log base 6 of 3 to the 9th power. So what I'm going to do is, because I have an exponent here, I get to use the power rule. I get to move it out in front. So we're going to have 9 times log base 6 of 3. Okay, so then I'm asking myself, log base 6 of 3, can I simplify that? Can I take 6 to a power and have it turn into the number 3? Well, it would have to be some kind of fraction if it's possible, because remember, 6 is the base, that's bigger than 3. But square root of 6 isn't going to get me 3. Cubed root of 6 isn't going to get me 3, and so on and so forth. So I can't simplify that down any further. So then this would just be my answer. Because the second example, I don't see an exponent, the first thing I'm going to do is I'm going to rewrite this radical into an exponent. So we'll have the natural log and then x, and now because it's the cubed root, that's really 1/3. So now we're kind of back to then the first example. Now I see an exponent. I get to use that product rule. I get to move it out in front. So we'll have 1/3 times the natural log of x. Can't simplify the natural log of x, so this is going to then be my simplified expanded answer. In this last example here, notice that we have an exponent, so I get to take the 2, I get to move it out in front. So we're going to have 2 times log of the quantity x plus 4. Okay, so because that parenthesis has x plus 4, it's addition, so we're not going to be able to expand that any further. Okay, if it was multiplication, then we'd be able to. But right now, I can't do anything to expand that. So this would just be my simplified answer. All right, go ahead, pause the video, and see if you can use each of the three properties that we just learned about to expand to the fullest. Okay, so hopefully we should have gotten for the first one log base 2 of 3 plus log base 2 of x. For the second one, we have natural log of 4 minus natural log of e. So don't forget, natural log of e is really log base e. So those are inverses. So my final simplified answer, natural log of 4 minus 1. And then in this third example, I moved that exponent out in front. So 5 times log of y is my answer. All right, so now that we have those three properties down individually, a lot of the times we're going to have multiple properties put together in the same example. So we're going to use all of those properties to expand each expression as much as possible. So here we have log base b of x to the fourth times the cubed root of y. So the first thing that I notice is that we've got multiplication. So multiplication means we want to use the product rule. So that means I want to take log base b of x to the fourth, and I want to add log base b of the cubed root of y. Okay, so we've expanded through addition, but notice how in the first term we have an exponent, which means we get to use the product rule. I get to move that 4 out in front. So we're going to have 4 times log base b of x. If you notice that the second term here has a radical, I'm going to go ahead and think of it in terms of an exponent. The cubed root is the same thing as an exponent of 1/3. So we get to continue to simplify. That 1/3, we get to use the product rule. That gets to move out in front. So 4 times log base b of x plus 1/3 times log base b of y. Because we're dealing with variables for x and variables for y, and even our base is a b, we're not going to be able to simplify those down any further. So we got rid of the multiplication, we got rid of the exponents, and so this is our expanded answer. So we use two properties, the product rule and the power rule. If I take a look at the next example, we have log base 5 of the square root of x divided by 25y to the third. So first thing I'm going to do is I see parentheses, I see division. So let's use that quotient rule. We'll have log base 5 of the square root of x minus log base 5 of 25y cubed. Okay, next thing I notice is that in the first term, a square root can really be written as an exponent. So that's really x to the 1/2 power. Notice that in the second term, I see multiplication. So that means we get to break apart those two terms using then the addition. Okay, we're using that product rule. So I'm going to take the subtraction, but then I'm in parentheses, I now want to break apart the second term. So it's going to be log base 5 of 25 plus log base 5 of y cubed. Okay, we're still not done. I noticed that in the first term, we have an exponent. So using the product rule, I'm going to move it out in front. So we'll have 1/2 log base 5 of x. Notice that we have log base 5 of 25. Well, I can simplify that. 5 to what power is 25? Well, 5 squared is. Notice that in this third term, we have an exponent. So using the product rule, I'm going to move it out in front. So we'll have 3 times log base 5 of y. Okay, I can't simplify the first term any further because there's a variable of x. I can't simplify the last term anymore because there's a variable of y. But the last thing that I can do is I can distribute that negative so I can get rid of the parentheses. So our final expanded answer is 1/2 log base 5 of x minus 2 minus 3 log base 5 of y. Notice how, because there were two terms in the denominator of my original problem, that means that I needed to have two subtraction signs. Okay, so however many terms, we have a 25 and we have a y cubed. We had two terms. However many terms were in the bottom, because it was division, that's how many subtraction signs we should end up with at the very end of this problem. All right, go ahead and pause the video and see if you can use multiple properties within one example to expand as much as possible. So with the first one, hopefully we notice that we have multiplication. So we have the product, which means I could break it apart using addition. Log base 3 of 27 plus log base 3. And then I wrote that 4th root of x as x to the 1/4 power. Log base 3 of 27 can be simplified. 3 to the 3rd power gets you 27. So that's why it simplified to the number 3. I moved the exponent of 1/4 out in front, and that's as much as I could expand with the second term, so that was my final expanded answer. Notice that in the second example here, started with division, so I knew that I needed to subtract. Notice how there's only one term in the denominator, so that's why there is one subtraction sign. Notice that I have two terms in the numerator, so technically we have the natural log of 6e to the 3rd minus the natural log of 7. So I went ahead right away and I knew, okay, there's a product happening, which is why it got broken up into addition there. And then I went ahead and I saw that I had some exponents, especially here. So I moved that exponent out in front. And then finally, natural log and e are inverses. Those we're going to simplify down. That's really log base e of e. So that's simplified to the number 1. So 3 times 1 is why the middle number was just a 3. All right, so a lot of information, but as long as you practice, you'll get the hang of it. So that's the product rule, the quotient rule, the power rule, and the expanding these log expressions.